Have you ever wondered how a simple magnet can hold so much power? It's a question that has intrigued humans for centuries. Welcome to the captivating world of magnetism, an invisible force that rules our everyday life in more ways than we realize. From guiding ancient navigators across the vast oceans to powering modern technology, magnetism is an integral part of our world. It's not just about sticking notes on your fridge. Magnetism is not just a phenomenon, it is a fascinating journey through time. Our journey begins in ancient Greece, where magnetism was first discovered. It's a tale as old as time, dating back to a shepherd named Magnus. Legend has it that one day, while tending to his flock, Magnus stumbled upon a peculiar rock. The iron tip of his staff and the nails in his sandals clung to the rock, sparking curiosity and wonder. This strange rock, later named magnetite after Magnus himself, was the world's introduction to magnetism. The Greeks were fascinated by this natural phenomenon and began to explore its potential. They found that these magnetite rocks, or lodestones as they called them, could align themselves with the Earth's natural magnetic field. This led to the creation of the first compasses, revolutionizing maritime navigation. Magnetism, a word derived from Magnus's name, thus became an integral part of our language and scientific understanding. The Greeks may have been the first to discover magnetism, but they were certainly not the last. As we move into the Middle Ages, magnetism begins to take on new dimensions. It's during this era that the compass, a device that would change the world, was developed in China. You see, the compass utilizes the Earth's magnetic field to point north, providing a reliable means of navigation for seafarers and explorers. This brilliant invention made long-distance travel and exploration possible, opening up the world in ways previously unimaginable. Now, let's fast forward to the 16th century to meet William Gilbert, an English physician and natural philosopher. His book, De Magnet, published in 1600, was nothing short of groundbreaking. It was the first major work to argue that the Earth itself is a magnet. Gilbert conducted extensive experiments using lodestones, naturally magnetized pieces of the mineral magnetite, to demonstrate that the Earth's magnetic field extends into space. He also introduced the term magnetic pole, and was the first to understand that these poles are the areas where the Earth's magnetic force is strongest. His work was revolutionary, not just for its scientific findings, but also for its methodology. Gilbert was among the first to use careful observation and experimentation to study the natural world, a cornerstone of modern scientific practice. Gilbert's work laid the groundwork for future scientists to further unravel the mysteries of magnetism. Enter the 19th century, a time of great scientific discovery and understanding. This era was marked by the groundbreaking work of scientists like Hans Christian Ørsted, André-Marie Ampère, and Michael Faraday, who collectively uncovered the mysteries of electromagnetism. Ørsted, a Danish physicist, was the first to observe that electric currents create magnetic fields. During a lecture in the early 19th century, he noticed a compass needle deflected whenever an electric current from a battery was switched on or off. This was a revolutionary discovery, as it linked the previously separate fields of electricity and magnetism. Building on Ørsted's work, French physicist André-Marie Ampère formulated a mathematical description of the magnetic field produced by a current carrying straight conductor. He showed that the magnetic field circulates around the conductor, with its strength proportional to the current and inversely proportional to the distance from the conductor. Michael Faraday, an English scientist, took these findings further. He discovered electromagnetic induction, the principle behind electric generators and transformers. Faraday showed that a changing magnetic field in a circular loop of wire induces an electric current. He also demonstrated that a solenoid, a coil of wire, produces a magnetic field similar to that of a bar magnet when an electric current is passed through it. These discoveries were instrumental in understanding electromagnetism. The concept of a magnetic field produced by a current-carrying conductor underpins many modern technologies, from simple electric bells to complex MRI machines. The solenoid in particular has wide-ranging applications, including in car starters and doorbells. The 19th century was a golden age for understanding magnetism, setting the stage for its modern applications. In the modern era, Magnetism has become an integral part of our lives. We encounter it every day, often without even realizing it. From the simplest of compasses to the most complex of technological devices, magnetism is at work. It's the unseen force that keeps our world spinning, quite literally. Let's talk about electronics, for instance. Magnetism is the backbone of many gadgets we use daily. It's in our smartphones, computers, TVs, and even our vehicles. The hard drive of a computer, which stores all our data, uses magnetism to encode information. Similarly, the speakers in our devices use magnets to convert electrical energy into sound energy. And it doesn't stop there. Magnetism has also found its way into the field of medicine. Ever heard of an MRI scan? That's magnetic resonance imaging for you, a non-invasive technique that uses a magnetic field and radio waves to produce detailed images of the body's organs and tissues. It's been a game changer in diagnosing and treating a host of medical conditions. But this is just the beginning. As we delve deeper into the world of magnetism, we continue to uncover new applications. Be it in space exploration, energy production, or even quantum computing, the potential of magnetism is vast and largely untapped. From the ancient Greeks to the present day, the journey of magnetism continues to fascinate and amaze. So what have we learned about the intriguing world of magnetism? We've journeyed from the ancient times, where the first instances of magnetism were discovered in naturally occurring minerals like lodestone. These early humans were mystified by the invisible forces at play, leading to the creation of the first compasses. Then we moved into the Middle Ages, where magnetism started to be studied in a more structured way. It was during this era that the concept of a magnetic field was introduced, shedding light on the invisible lines of force surrounding a magnet. Our journey then took us to the age of electromagnetism. This was a significant leap forward in our understanding of magnetism, as it revealed the relationship between electricity and magnetism. We learned how a current-carrying straight conductor can produce a magnetic field, and how this principle is applied in devices like solenoids and circular loops. Finally, we explored the modern applications of magnetism. Today, magnetism is integral to numerous technologies that shape our everyday lives, from the humble refrigerator magnet to complex MRI machines in hospitals. But remember, our understanding of magnetism is far from complete. There are still many mysteries left to unravel, and who knows what exciting discoveries await us in the future. Understanding magnetism is not just about science, it's about understanding the forces that shape our world. Until next time, keep exploring.